Hello everyone, welcome to my YouTube channel. Today I'm going to go over the Leetcode question 200 number of island. I'm solving it using union find algorithm. So let's try to first take a look at the problem statement. Given an m times n 2D binary grid, which represent a map of ones, 1 means land, and zeros, 0 means water, return the number of islands. So island is surrounded by water and is formed by adjacent lands, horizontally or vertically, which means 4 directions. You may assume all 4 edges of the grid are all surrounded by water. So in that case, with this assumption, which means the grid boundaries are also considered as water. So in that case, let's try to take a look at the examples. In the first example, we have a grid like this. So there is only one island in this grid. So you can see that all the ones are actually connected to other ones. And then they are also surrounded by zeros, which means water. So take a look at this one. It has an island cell above it. So if we're going up, we encounter an island cell. And then if we're going left, we find water. And then if we're going right, we find water. If we go down, we find water again. So there is only one island in this grid. Now let's take a look at example 2. There are 3 islands in this grid. So the first island is these 4 ones. And then the second island is this one in the middle. So you can see that waters in the 4 directions, up, left, right, down. There are ones diagonally, but according to our definition, we don't consider these cases. So in this case, this one has water surrounded in 4 directions. So we consider this one a standalone island. So in this case, we got our second island. And then the third island are these 2 ones here. So in total, we have 3 islands in this grid. So now we fully understand the problem. So remember, 1 means land, 0 means water, and then it's surrounded by water. Island is surrounded by water in 4 directions. So the idea of solving this using union find is very simple. Basically, we union each island cell with its neighbors, if the neighbor is an island cell as well, to form the same island. So basically, that's the overall idea of solving it. So before solving it utilizing union find, let's first implement the union find in Python as well. So we define a class called union find, and then we do some initialization. So remember, in the union find, we specify the number of elements. I also posted another video to go through to explain the union find algorithm in details. So if you want to know more details, please feel free to check my other video. So first, we specify what's the number of elements here, and then we initialize the parent. So initially, the parent, each element's parent is itself. And remember, we want to utilize the path comparison. So we specify the rank. So at the very beginning, each element has rank of 1, which means it only has one child, and then that child is itself. So let's implement find. Basically, given an x, we want to find its parent. So in this case, we want to utilize path comparison, which means, like, let's say if this given element x, it is not this x is not itself's parent, which means it belongs to a subset, and then it has a parent in that subset. So we want to find its parent. And then we also want to perform the path compression. So okay, sorry, forget the self. So path compression means that we assign the grandparents to be its new parents to avoid creating a chain, a very long chain. So basically the idea for this one is let's utilize path compression. Utilizing path compression, we assign the grandparents as the new parent of this element. And then we keep finding the parents by going up the chain, which means, let's say, we try to first find the given element's parent. And then if the given element's parent is not actually the parent of the subset, we're trying to find its parents as well. So now let's code union. For union, we have two elements, x1 and x2. We are trying to combine them into the same subset. So how to do that? First, let's try to find the parent utilizing the find function we already coded. Okay, so if they have the same parent, which means these two elements already been merged before. So let's say in this example, we just return 0. So we do nothing. They already been union before. If not, let's say we just compare their rank. If self.rank p1 greater than self.rank p2, which means p1 has more children than p2. So based on how we want to optimize the union find algorithm, we want to assign the element with more children as the new parent when we combine the two subsets. So in this case, self.parent p2 equals p1. And then after that, don't forget to update the rank because now p1 has more children after the union. So which means self-rank p1 equals itself plus all the children in the other subset. Else, so in this case, so it's something similar. So, but in this case, we just assign p2 as the parent of combined subsets. So now we just, after union, we return 1 to indicate, okay, we have already completed the union operation and then formed combined subsets. Now we finish implementing the code for union find. So now let's try to code the solution to the number of island. So let's try to first get the dimensions for the input grid. So we get the number of rows and then the number of columns. And then we try to initialize the union find. So remember, as the input for initialization, we need the number of elements, which is the total number of elements in this grid, which is m times n. And then throughout the entire union and find operation, we will try to flatten out the index of each element in this grid. So let's try to loop through every element in the grid as well. So basically for I in range m, for j in range n, we check if grid I, j is an island cell. And then in this case, we are trying to combine and perform union option with the adjacent cell if the adjacent cell is also an island piece. So in this case, we only combined with the cell below it and the cell to the right. So we can consider that we are actually moving in two directions, going down and then going to the right. Why? To avoid redundant union with the cell that's already occurred. Let's say when we were at the cell to the left of existing cell ij, which means when we are at the cell I minus I j minus 1. So this cell is to the left. In that case, we already combined perform union option with the adjacent, with the current cell, which is the cell ij, if both of them has value 1, which means both of them are LNPs. So we do not want to perform duplicated or redundant union operation. So in this case, we simplified into two directions. Look at the cell to the right and then look at the cell below it. Okay, so first let's going down. Look at the cell below it. That the index for that cell is I plus 1 and j. So in that case, if great, so first we want to make sure the index of the cell below it is within the range, which means if I plus 1 is less than or equal to m minus 1, and it is also an island cell. Sorry, the index I plus 1. In this case, we are trying to perform the union find operation. So basically, UF the union. Okay, so remember, we represent each element in this grid with the flattened index in the union find data structure. So how to do that? So for example, let's try to first represent the current one. X1 equals the M times J. And then in this case, X2 equals I plus 1 times J, which is just the sorry, my bad. So the index is actually not x times j. So the index for x1 is x times n plus j. So basically, so before x1, so we have and actually for example, let's take a look at this. If I equals 0, in this case, x1 just equal to j, which means it's the j's elements in this flat out index. So if I equals 1, the position of this one is x1 equals n plus j, which means it's the n plus j's elements. So in that matrix, if we trying to represent it in a 1D dimension. So in this case, we can simplify x2 into just x1 plus n. And then we perform union find to x1 and x2. Okay, so far we haven't really keep track of the number of islands. So let's first initialize it to 0. And then every time when we encounter an island piece, let's say grid ij equals 1, we increase the number of islands by 1. And then every time we perform the union operation, let's say we just minus this one. Let's say if we can perform a union by combining x1 and x2, In the above implementation, we return value 1. So in this case, if it's combined with the previous Allen piece, there is no need to do the original increments. So after increments, we just deduce that from the total counts. So similarly, we can go right. So going right, the cell to the right of it is ij plus 1. So in this case, if j plus 1 less than or equal to n minus 1, make sure they are within the index range. And then grade I, j plus 1 equals 1. In that case, my x2 is equals x1 plus 1. And then count equals uf dot union x1, x2. Remember, uf dot union x1, x2 return 0 if not combined. Oh, my bad, self the parent. So let's try to submit it. Yep, so actually let's go back and review the unified solution. So we first code the unified architecture, and then in this case, we indicate that if we did not combine them, we just return 0 as the return value for function union. If we successfully combine them, we return 1. And then when we try to solve the number of islands, we initialize the unified data structure. And then we utilize the total number of elements, m times n. And then we keep a variable count to keep track of the total number of islands. And then we are trying to loop through this entire grid. And then every time we encounter 1, which means island piece equals 1, we try to increase the count by 1. By first assume it's an independent island before try to union it with the neighbors. So let's say in this case, we are trying to union with the neighbor below it and to the right of it. So by trying to union with the neighbor below it, so we get index for that neighbor, which is I plus 1, and then j. And then we need to check if I plus 1 is within the range. And then if that cell is actually an island cell. So if both conditions satisfies, so we just get a flattened out index x2 for this cell, which is x1 plus n. Remember, it had it's the cell below it. So and then we update the count, the number of islands. If we can successfully union these two islands, which means that we can reduce the number of islands by 1 because we already combined them together. Similarly, we are checking and then do union with the cell to the right of it. And then after that, we just return the total count of the total number of islands. So yeah, so that's the solution for solving it utilizing union find. So why we want to solve it using union find? It seems like more complicated ways. So I have more lines of code because I have to first code up this union find class. So in this case, if we only look at the original problem for the number of islands, we do not need to utilize the union find solution. The DFS is sufficient and it's much simpler. I would say less lines of code. But let's say, what if your grid dimension is not fixed? So you want to keep expanding it, and then every time you expand the grid, you want to check, okay, if how many islands you can form. So in that case, it's hard to perform the depth first search to solve that problem because we do not have a fixed size of grid. So in that case, union-find solution is a much better one because regardless what's already in the grid, every time we expand the grid, we can just check the new cell in that expanded section and then to see if we can perform union operation with the existing cells already in the grid before the expansion. So in that case, the union find is actually a perfect solution for that. And then in the real world, we are trying to solve a lot of different problems. Union find is also a good solution. So that's why we are trying to implement this number of island union find, just trying to demonstrate how we can solve it with union find solution. So if you are interested, you can go to the other Leetcode problem, number of islands too. So that one will require you to actually utilize the union find method to solve it. So that's the end of my video. If you like my video, please feel free to subscribe to my channel. And then I will also publish more videos. Thank you.